All right, welcome to STAT1800. My name is Dr. Darbro. I've created all the instructional videos for the course, and so you're going to hear me a lot in the upcoming lessons. Um, I may or may not teach the class, but whoever teaches the class, I encourage you to reach out to them if you have questions. So let's get to it. The purpose of this video is just to cover some definitions and vocabulary that we will use quite a bit. So, kind of setting a framework, if you will, to so we can communicate with each other about business statistics. So, an operational definition is statistics is just the science of collecting, analyzing, and interpreting data. The collection phase is obviously extremely important because if we collect bad data, then we end up getting bad results. The analyzation phase, that's primarily what I teach you in this class. And then the interpretation, once we analyze the data, what do the results tell us about interpreting the data and making, potentially in a business application or business context, making improvements. So we're talking about data. Data is just facts, statistics, or items of information. And trust me, I'm not going to read all this to you, but there are going to be certain places where I will read to you. I always hate it when somebody reads a PowerPoint to me. So I provided a few scenarios there where we may collect data. I think the last one's kind of interesting because I am posting this, or actually creating this video in March 2022, and we are smack dab in the middle of the NCAA tournament. So I've always wondered with my statistics background, could I come up with this set of characteristics, maybe defense efficiency or free throw or, whatever, number of wins, conference, whatever. What characteristics may predict wins in the NCAA tournament? So anyway, data can take on a lot of different types of values. Now, something very important, well, it's all important, but this is extremely important, is to understand that our data may come from a population or a sample. Now, the population is just the entire group of subjects, elements, dogs, cats, trees, whatever it is that we are studying and collecting data about. Typically, our population is so large we can't collect data on every single subject in the population, so we depend on a sample. And a sample is just a subset of the population. Now, as we'll talk about later in the video, in this video, we typically seek out a random sample. So again, I'll talk about that just a little more later. So the primary goal of statistics is to analyze data from a sample to make a statement or estimate about a value from a population. So for example, I'm posting this video in 2022, as I just said. In 2024, we're going to we're going to have another presidential election. So people at before the election, they want to know which candidate is quote unquote winning. So the population would be all people who are likely to vote, and the population value would be of all those people, how many are going to vote for candidate B, how many are going to vote for candidate C, and so on. Well, we can't ask everyone in our population. So again, we would take a sample and analyze the sample to make that estimate. Now, I think now's as good a time as any to kind of pump the brakes and let you know how I hope you'll approach the class. I hope you'll approach it just like you would if you were in a face-to-face class. Take notes, get organized, get structured. Come to class in the online format. That is watching the instructional videos and utilizing the instructional resources that I provide in the class. So this is one of those things that should go in your notes with big old flashing neon lights around it because it's extremely important. Different types of variables that we run into. One type is called categorical. That's just where the variables take on categorical values, political affiliation, gender, favorite NCAA football team, eye color, things like that would be categorical. Numerical are, as you would expect, they're quantitative variables. And again, we call them variables because in statistics, we need variation. So, for example, circling back to the categorical variable, uh, if if I'm in a class where I have all one gender, then that variable is of no interest to me because it doesn't vary. It's just one gender, right? Um, so if I'm in a class where I'm analyzing height, and everyone in there is 5'7", it'd be kind of strange, but and odd and not likely. But let's just say, for the sake of this narrative, that everyone is 5'7", then the data of interest height is of no use to me because it doesn't vary. So that's the reason we call it variable. Numerical variables just take on measures that are counted or have a measured quantity. So we call a measured variable a numerical quantitative variable that arises from a counting process, discrete variable. So the number of texts that you receive in a day, the number of social media accounts, uh, the I don't know. You can come up with all kinds of different things that involve a counting process. A continuous variable, on the other hand, measures is a result that comes from a measuring process. So height, you wouldn't count your height, you would measure it. Weight, you wouldn't count your weight, you would measure it. Your ACT, you wouldn't count it, you would measure it. Ounces in a venti cup of coffee at Starbucks, again, you wouldn't count the ounces, you would measure the ounces. And wait time at Tim Hortons, and probably minutes, would also be measured. So there's a distinction between the types of numerical variables that we get. Again, one being discrete, countable, the other one being measurable. We call those continuous. I have to be very careful. Sometimes numbers and categories actually meet. In other words, sometimes we express categorical responses with numbers, and we do that just for convenience in the spreadsheet. But again, don't be misled that just because you look at a spreadsheet and you see a bunch of numbers, it doesn't necessarily mean that the variable is quantitative. For example, for a Likert response from a survey, we see 1, 2, 3, 4, 5 used very often, but those really aren't numbers. They don't count anything. They don't stand for any measurement. They just stand for a placeholder for either, like strongly agree, disagree, and so on and so forth. Collecting data obviously is very critical. Again, just trying to set the foundation here to where when we get to lesson 3 or 4 or 5, a future lesson, and I mentioned bias, then you know what it is. So a bias is just a deviation from the truth, and poorly collected data will lead to a biased result. I had a study. I taught statistics at the University of Kentucky a few years ago, actually quite a few years ago. I've been at Shawnee now for 28 years, uh, and I've taught statistics at Shawnee over 100 times. But before I came here, uh, actually, I was already here. I was teaching a part-time class at UK. We did a project, and I had a student who wanted to. Uh, that particular year, the University of Kentucky basketball team was in the Final Four, and she wanted to estimate the percentage of students at the University of Kentucky who watched the Final Four game. And so she came to me. She said, "Well, something really weird. I sampled like 100 people, and every single person watched the game." Well, I found that pretty strange because even though basketball is really popular at the University of Kentucky, not everyone cares, right? Uh, so what she had done is she had gone on a Friday night or Saturday night to a local sports bar and taken her sample. Well, her data conclusion was completely meaningless because she had collected her data so inappropriately. What she should have done is just taken a random sample of students at UK, not students at UK who hang out in a sports bar and are more likely to have watched the game. So, final bullet, the most effective way to reduce bias is to collect a random sample. That statement needs to go in your notes with big, bold letters. Uh, this class, business statistics, as you would imagine, tends to focus on business applications. So, a few business objectives that could uh, uh, present itself and be appropriate for statistical analysis. If a marketing analyst wants to assess the effectiveness of a new television advertisement, what they may want to do is they would look at the sales before the advertisement was implemented and then look at the sales after the advertisement was implemented to see if there is a statistically significant difference. A pharmaceutical manufacturer may want to determine if one drug is more effective than the other. In that case, you'd probably have a control group, people who are using the drug that's currently in use. You would have an experimental group, people who are using the new drug, and you would see if there is a difference. Final bullet there, an operation manager wants to examine a new manufacturing process to determine if the quality of the new product is conforming to company standards. 5 categories for studies. We have organizational, we have survey, we have business activities. I'm not going to read these to you, but you will notice that the second one and the fourth one are highlighted. They're bolded. That's the reason. The reason is I want to bring attention to that. One type of study we see is an experimental study. And an experimental study typically includes something called an intervention. Now, I don't necessarily mean intervention in terms of some sort of counseling, but I mean broadly speaking, an intervention. So uh, a company is doing something, they have a practice, they intervene with some program broadly defined, and then they measure the results after the quote unquote intervention. Let's say Tim Hortons is seeking a way to make wait times from maybe 8 a.m. to 10 a.m. Uh, well, I guess the wait times would decrease. They want to make service faster. So what they may want to do is they would uh, evaluate on average how long people wait to be served from 8 a.m. to 10 a.m. They may intervene with the professional development, some way to some program geared toward decreasing the time patient shoot. I'm thinking about another example as I'm speaking. Thinking about the time that their customers wait, and then of course measuring the time after the intervention of professional development. An observational study, on the other hand, doesn't do anything. An observational study is kind of lazy. You just kick your feet up, and kick off your shoes and sit back and just observe something that is happening. So measuring the time it takes for customers to be served in a fast food establishment would be an observational study. Now, you can turn that into an experimental study by, again, implementing some sort of intervention, well, professional development, as I uh, just talked about. Types of samples. What I want you to think about here is there are non-probability samples and probability samples. Let me explain that further. A non-probability sample is where items, people, subjects, elements, dogs, cats, trees, whatever it is, are chosen without regard to the probability of the occurrence. One of the least effective sampling methods is called a convenience sample. And you see these a lot when we're trying to predict which presidential candidate that people are going to support, because we go to malls, we go to shopping centers, broadly defined, we go to grocery stores. we get our samples there. Why? Well, because it's convenient, right? Or you have a news organization, whether it be Fox News or CNN or MSNBC, whoever it may be, who puts a poll on the screen and then people call in. Well, that's easy to get, right? It's a convenience sample. And at the end of the day, when I see that data has been collected by a convenience sample, I automatically just draw a line through it and say meaningless results. Judgment sample, this is the one that always uh, uh, entertains me, if I will. In fact, I was just at a Christmas party, and a friend, acquaintance, I don't even really know how to classify this guy. Uh, and I will tell you, he's way too political for me. He was trying to make a political statement, and he was justifying his political statement because a friend of his, who was a retired Marine corporal, felt that way. Well, I have a good friend who is a retired Army. I think I forget where. Anyway, he went to West Point, and he was very high ranking. Felt the other way. So uh, when you appeal to authority, you have to be extremely, extremely careful. Probability sample. There are four different types: simple, random, systematic, stratified, and cluster. Let me give you examples of each of those. Simple random sample is where every item from our population has an equal chance of being selected, and is by far the most effective way to reduce bias deviation from the truth. A systematic sample. This is a little more complicated, but what you do is you decide on your sample size. Uh, and let's just say their sample size, we want 4 people. So we divide the total, and I'm bouncing this off of these values down here. So we take 40 individuals and we decide we want 4 in the end. So if we have 40 individuals and we want 4, we'll take 40 divided by 4 and we get 10. So each group will have 10 observations. And this actually looks like the way you have to stand when you're going through airport security, doesn't it? So anyway, sorry. So what you have there is you have 10, again, subjects selected. The next thing you'll do is you'll select a number at random. In this case, it looks like they selected 1, 2, 3, 4, 5, 6, 7. They selected the number 7 at random. So they'll go through and select the 7th person, the 7th person, the 7th person, and the 7th person um, as their sample. Now, caution, systematic sampling is a horrible process for any kind of machine production, if you will, because what you'll find is sometimes errors, defaults in the production process can be systematic. In other words, I've seen machines fail on like the 11th run consistently. Well, if you just happen to set up your systematic sample where you're choosing the 11th quote unquote individual, the 11th ball bearing, the 11th product, then you're going to get results that indicate that your manufacturing process is failing or producing default or faulty whatever it is, a widget, wheel bearing, whatever the product is. It's So again, systematic sampling, in my opinion, when you're analyzing the quality of a manufacturing process, is a horrible way to proceed. Stratified sampling is very similar, but in this situation, you divide your population into groups, and we just call those subgroups or strata. And each of these people in a strata have something in common. So what happens, this is commonly used when sampling population of voters. If you want to stratify uh, across racial or socioeconomic lines, let's just say that we want to uh, uh, get a population, a sample of voters, and our socioeconomic status are high, low, and middle. So that would have 3 subgroups: high, low, middle, and I would select a random sample from each. So in the end, I would combine all the samples from the subgroups to create my random sample. Cluster sampling, very related but different. A cluster is where we divide our population into different groups, if you will. Now, an example that I like to use here is think about if we wanted to examine uh, some measurement on high school seniors. Well, our clusters could be these high schools. So what I may do if I was wanted to examine this in the state of Ohio is I would have all these high schools that are my clusters. Well, I would randomly select, uh, maybe 3, 4, 5 high schools, and then dive into my high schools and select my sample from each of the high schools. Common application is selection exit polls. Instead of going to every polling station, people will choose, 3, 4, 5 exit polls and then sample people as they leave the poll to try to determine who they voted for. I always lie to them, so there you go. All right, we're done. So if you're still with me, thanks. This is a motivation to always watch the instructional videos completely. So your first discussion forum post, which is due on Blackboard. If you go to Blackboard, it's over in the left pane. You'll see a link that says discussion. So the first question, give an example of data that may be collected on SSU students that is quantitative and discrete. Remember, quantitative is a number, discrete is countable. The second, same thing, except quantitative and continuous, so something that is quantitative that would be measured. The third thing, give me an example that is categorical. And then finally, design an experiment that would use a stratified sampling process. Going to have to be a little creative here. I don't want you to write a novel. Just you should be able, in 2 or 3 sentences, be able to describe an experiment that would use a stratified sampling process. And just to make it fun, let's just say that you want the stratified sampling process to be implemented at Shawnee State University on our students. All right, thanks for hanging around.